Hello, my name is Dan Ruter and I will present our work on fine-grained style similarity representation learning. First of all, when we say style, we refer to the visual appearance of an image in terms of visual aspects and attributes, not necessarily considering semantics. Some datasets already exist with such labels, like the BAM dataset, but they are limited to only coarse level style labels. And by coarse labels, we mean very broad labels such as watercolor, oil, sketch, and so on. Whereas with fine-grained labels, we mean labels which look at much more minute differences between styles. This diagram on the right should give you a good example of what we mean. All these images would fall under the same penning coarse style, but they are all clearly different in other attributes such as stroke width, paper color, lightening, and so on. A large-scale dataset of this type has not been collected before, likely due to it requiring an impossible amount of work. Such a dataset will need many expert artists with deep knowledge of all styles to create an ontology for millions of images, all while agreeing with each other on every cluster. In our work, we present two main contributions. First, BAMFG, a new large-scale dataset of fine-grained style labels, as previously described, and second, ALADIN, a new model architecture with both implicit and explicit content and style disentanglement. For BAMFG, we use data from Behance.net, a platform where artists can share portfolios of their work in projects which we noticed are very fine-grained style consistent. Every artist has their own particular style. We extract millions of such images with over 100,000 style groups, and we further clean these via a large-scale crowd annotation exercise on Amazon Mechanical Turk. We use worker consensus to create several tiers of style consistency strengths. Here you can see a few examples of the cleaned style clusters, and on the right you can see some examples of before and after the cleaning process. Our model, ALADIN, was designed to disentangle style and semantic content in two primary ways. First, implicitly through the architecture. The style encoder extracts only global style features via AdaIN statistics. These are extracted from several layers in the encoder to capture style information from multiple levels of feature abstraction before being concatenated into the style embedding. This style embedding is later split again and used in the decoder as mean and standard deviation values to perform AdaIN-like style transfer on the decoder features. The AdaIN values are matched between encoder and decoder positions, where statistics from early encoder layers are used in late decoder layers, and values from late encoder layers are used in early decoder layers. The second signal for disentanglement is via the BAMFG style cluster labels learnt through a supervised variant of the SimCLR contrastive loss. When compared to a baseline model such as ResNet, ALADIN relies less on semantic content. We notice, however, that these embeddings are complementary, and fusing them via concatenation actually helps push our metrics even higher. The strengths of our two contributions are very apparent when comparing to another baseline model, DML, where they explicitly trained such a discriminative model on a handful of coarse style labels. Our model, having never seen these labels, beats the fully supervised model trained with the explicit labels, and we thus set a new state-of-the-art score on coarse style discrimination. We further demonstrate our contributions on a fine-grained image retrieval case using style groups unseen during training. Please refer to our paper for more information and more ablation studies on this. We further evaluate the fine-grained performance of our models against baselines via user studies conducted on Amazon Mechanical Turk, which further support our automated metrics. Finally, we conduct some additional experiments using multiple style images as queries when performing image retrieval, showing that our embeddings are compatible with this setup. Thank you for listening. I leave you with a demo of web-scale image retrieval search using ALADIN.